We can solve a system of equations by using something called the elimination method. And the elimination method is sometimes called the addition method. And what we do is we look at our system and we look for opposites or additive inverses. If the additive inverses are in place, then we can add the two equations together and cancel variables. If the additive inverse is not in place, then we can create one by multiplying one or both equation by some factor in order to create the opposite. Let's look at the first example. It's pretty easy. I've got 3x plus 4y equals negative 10, and I have x minus 4y equals 2. So when you're using the elimination method, the first thing you want to make sure is that each equation is in standard form. You want to line up your x's and your y's because you're going to add the two systems together. And I've done this already. Both are in standard form. Then you look at your system to see if you already have opposites in place. So here I have a 3x and a 1x, so these are not opposites. Here I have a plus 4y and a minus 4y. These are both opposites or additive inverses. Since these are already in place, I can go ahead and add my two equations together. When I add them together, the plus 4y and the minus 4y are going to cancel out. So I have 4x, because 3x plus 1x is 4x, equals a minus 10 plus 2, which is a minus 8. So now I have an equation that just has an x in it, and I can solve it for x. And I divide both sides by 4, so I get x equals a negative 2. So as you can already tell, the elimination method is a little faster than the substitution method. So already I've solved for a variable. I know that x is negative 2. Now the next part goes back to the substitution. It doesn't matter which equation I go back to, but I can go back to either one of these and plug in the value negative 2 to figure out what y is. So I would probably pick this second one because it's the easiest one to work with. The coefficients are small. I've got x minus 4y is 2. I know what x is. X is negative 2, so I plug in a negative 2 for x. So negative 2 minus 4y equals 2. I'm going to add 2 to both sides, so I get a negative 4y equals 4. And so y is going to be negative 1 because 4 divided by negative 4 is negative 1. So I know what x is. I know what y is. My solution should be negative 2, comma, negative 1. And just like with substitution, you can go back and check your answer. If I take the negative 2 and plug it in up here and take in the negative 1 and plug it up here, I should get negative 10. So 3 times negative 2 is negative 6. And a 4 times a negative 1 is a negative 4. So negative 6 minus 4 is negative 10, so it satisfies the first one. I'll plug in a negative 2 here. I get negative 2 minus 4 times a minus 1 would be a plus 4. So negative 2 plus 4 is 2. So it satisfies both equations. So it must be a solution to my system. Remember, it has to satisfy all the equations in the system, and that point, negative 2, negative 1 does. Let's look at this next example. Here I've got 3x minus 2y equals 4. And I have 5x plus 3y equals negative 25. My equations are lined up. I've got the x's over each other and the y's. They're both in standard form. But as I look at this system, I notice that I don't have any additive inverses in place. My x's don't automatically cancel, neither do my y's. So what I need to do is figure out, first, what variable do I want to cancel? Do I want to cancel my x's, or do I want to cancel my y's? And then once I decide that, I want to create an inverse. So it really doesn't matter which one you choose. Looking at this, I think I might want to get rid of my y's. So I'm looking at a negative 2 and a positive 3. So I try to think of multiples that involve the 2 and the 3. So what I could do is I can make this a negative 6 by multiplying by 3. So if I multiply this 2 by 3, I have to multiply that by 3, and then the 4 by 3. So I'm going to take this whole equation here, and I'm going to multiply it by 3. So that I end up with 3 times 3x is 9x. 3 times a minus 2 is a minus 6x. Sorry, 6y. And then 4 times 3 is 12. So what I did was I created a multiple of my first equation. These two equations are equivalent. It's just that the second one I took the first one and multiplied it times 3. So now I go to the second equation. In the second equation, since this is a minus 6y, I want this to be a plus 6y because I want to make them opposites so that when I add them, I cancel. So to make this 3 a 6, I have to multiply it by 2. So I'm going to take this whole equation and I'm going to multiply it by 2. Now your factors do not have to be the same. They can be different. Okay, so I take this 2. 2 times 5 is 10. I get 10x. And then 3 times 2 is 6, so plus 6y. So here you can see the additive inverse is in place. I've got some opposites. And a negative 25 times 2 would be a negative 50. And again, remember, even though this looks different from the first equation, over here it's still the same. It's equivalent. I just took the first equation times 2. It means the same thing, just the numbers are a little bit bigger by a factor of 2. Now I have opposites, so I can add the two equations together and I can get rid of the y's. And I get 19x equals a negative 50 and a 12. Let's see, that would be 8. I believe that would be 38, and it would be negative, a negative 38. Then I'm going to divide both sides by 19, and 38 divided by 19 would be a negative 2. So x would be negative 2. Now once I figure out x, I can go back to either one of these equations and plug in a negative 2 for x. So it doesn't matter which one. I would just go with the first one simply because it's first. So I have 3x minus 2y equals 4. Now if I wanted to include the times 3 I could, but I really don't want to make my numbers any bigger than I need to, so I can go back just to the original problem. 3x minus 2y equals 4. Plug in a negative 2 for x, just like that. So 3 times negative 2 minus 2y equals 4. So now I can just solve for y. 3 times negative 2 is negative 6, so negative 6 minus 2y equals 4. I can add 6 to both sides and get a negative 2y equals 10. And then I can divide by the negative 2 and get y equals negative 5. So I have solved for my x. I have solved for my y. I know that my solution is going to be negative 2, put the x first, comma, negative 5. And again, you should check it real fast. If I plug in a negative 2 here, I get negative 6. A minus minus makes a plus, so negative 6 plus 10, which is 4, so that checks. I go down here, plug in a negative 2 here. I get 5 times negative 2 is negative 10, plus 3 times negative 5, which is negative 15. So I have a negative 10, a negative 15. It adds to negative 25, so it does check. And that satisfies all the equations, so it is a solution to my system. Let's look at this very last example. Here, I'm looking at my system, and I see that one of them is solved for y. Now, I could use substitution, true, but I'm asked to use elimination. So what I want to do is look at my system, and I need to take this and put it in standard form because I want to line my x's and my y's up. So the trick here is to line your variables up. So I'm going to take this 4x and move it to this other side. So when I bring it over, I get a minus 4x plus y equals a negative 12. And then here, I don't need to do anything to it because I'm able to line my x's up here. It's in standard form, 4x plus 2y equals 6. And then I'll look at my system before I decide to do anything else. I'm looking at the system, and I see I have opposites already in place. I see I have a negative 4x and a plus 4x. That means that will cancel. So that can go ahead and get rid of my negative 4x and 4x, and I get 3y equals a negative 12 plus 6, which would be a negative 6, divide by 3, so y is negative 2. Now, I know what y is. I go back to either equation. I probably would just go back to the first equation, plug in negative 2 for y, so negative 2 equals 4x minus 12, and I'm going to solve this one for x, which shouldn't be too difficult to do. I'm going to add 12 to both sides, and I get 10 equals 4x, and so x is 10 over 4. Now 10 over 4 will reduce to 5 over 2 if I divide both the numerator and denominator by 2. So it looks like my solution is going to be 5 halves, or 2.5, comma, minus 2. Let's check it real fast just to make sure that we've done this right. So I go back over here, and I can plug in a 5 halves for x. So I have, I'll go ahead and write this out so you can see it. Y is negative 2. Do this check real fast. 4 times 5 halves minus 12. Well, 4 times 5 halves. 4 times 5 is 20, and 20 over 2 is 10. So I have 10 minus 12. And 10 minus 12 is a negative 2. So that checks. Then I go to the second equation. I'm going to check that second one real fast too. I've got 4 times 5 halves plus 2 times a negative 2. I want to see if it's going to equal 6. Okay, it needs to equal 6 to be a solution. So 4 times 5 is 20. 20 divided by 2 is 10. And then 2 times a negative 2 is negative 4. So 10 minus 4 is 6. Guess what? It checks. So there you go. The solution is going to be 5 halves, or 2.5, comma, negative 2. So this is how you solve by elimination. You look for or you create your opposites, and then you add the two equations together in order to cancel the variable. And then you use substitution to find the value of the second variable. So go back, look at this, study it, come to class, see if you have any questions, and I will see you in class.